Introduction to electrical drives.
Drives. Drives are systems which employ for motion control. A driver is the prime mover for the motion control. If the electric motor is employed for the drive the machine, it is called as a electrical drives. Most of the people think electrical motor as the electrical drives. It is not like that. Electrical motor is the heart of the electrical drives.
What are the components of electrical drives? It consists of electric motor with suitable sources and power modulating devices, controlling unit, sensing unit, and load. This is the block diagram of the electrical drives. This is the block diagram consists of source, power modulator, motor, load, sensing unit, and control unit. The purpose of the sensing unit is to give the feedback to the control unit. If you're consisting of the if you consider it as the electric vehicle, you have to regulate the speed of the electric vehicle. For that, sensing unit is the must to regulate the speed, whether it is higher or lower. It will give the feedback to the control unit, and the control unit regulates to power modulators. Electrical sources. In India, single phase and three phase AC supplies are readily available in most locations, but it's the very low power drives are generally fed from the single phase sources, and the rest of the drives are powered from the three phase sources, except in the case of the traction drives, where even at very high power levels. Single phase power supply is used because of economy. Most drives are powered from AC sources, either directly or through a converter link. When fed directly from 50 Hz AC supply, maximum speeds of the induction and synchronous motors are limited to 3000 rpm. For higher speeds, conversion to higher frequency supply becomes mandatory. Low and medium power motors are generally fed from 400 volt supply. For high rating motors may be rated at 3.3 kilowatt, 6.6 kilowatt and 11 kV, and higher. In case of aircraft and space application, 400 Hz AC supply is generally used to achieve the high power to weight ratio for motors. Electrical machines. You all know that about the electrical machines. The electrical machines are most commonly used in electrical drives are DC motor, shunt series, compound, and permanent magnet. For induction motors, scroll cage, wound rotor, and linear. In the synchronous motors, it is the wound field and permanent magnets are used. In the special machines, brushless DC motors, stepper motors, and switch reluctant motors are used. Then it is the most important part is the power modulator. The power modulator performs one or more works. That is, it modulates the flow of power from the source to the motor in such a manner that motor is imparted speed torque characteristics required by the load. Second thing is, during the transient operation such as starting, braking and speed reversal, it restricts the source and motor current within the permissible values. We all know that during the start of the electrical vehicle, it requires the more power and it should be drawn from the source. It may overload it or may cause the voltage dip. Then it converts the electrical energy of the source in forms of suitable to the motor. Example, If the source is DC and an induction motor is to be employed, then the power modulator is required to convert DC into the variable frequency AC. Then finally, it selects the mode of operation of the motor, such as it may be whether it is the motoring or braking operation. Here we have listed this some of the types of power modulators. In this, it is difficult to classify the power modulators, that is controlled rectifier, that it will convert the AC supply into the DC converters, and inverters it will convert DC into the AC, and AC voltage controllers to AC to AC converters, DC choppers it converts DC to DC, and finally the cycloconverters for the frequency conversion. It's a sensing unit in the electric vehicle to regulate the speed and to measure the torque sensing and position sensing. For torque sensing, it is the how much load it can be carried in the electrical vehicles, or if you are going for a crane unit, it has to be known how much load it should be carried, and position sensing is where it has to be located. The and current sensing and voltage sensing from lines or from motor terminals, and the temperature sensing. To temperature sensing is the important parameter to know the temperature of the motors, to monitor its performance of the motor. The temperature plays a vital role. And these are some of the types of the electrical drives. That is, according to the mode of operation, it is classified as continuous duty drives, short time duty drives, intermittent duty drives. And from the means of control, it can be controlled as manual, semi-automatic, and automatic. And another main classification, it is the DC drive and AC drives. Depends on the source of input. According to the number of machines connections, it is classified as individual drive, group drive, multi-motor drive, and according to dynamics, that is dynamics and transient conditions, uncontrolled transient period and controlled transient period. I'm going to see about the industrial drives alone. There is industrial drives are classified into that is three types. There is a depending on number of machines. First one, it is the individual drive, group drive, and multi-motor drive. Gears are connected with that. Gears are connected, and it the power is transferred to the gears, and you can see that what are the operations carry out. It is in that it has been in the sugar mill. It has these videos are recorded. There is several operations that take place with this connecting with a single motor. Various operations are connected. This one or more line shafts are supported with the bearings and gears are connected. Here you can see the operations. What does it take place? On the multi-motor drive system, there are several drives, each of which serves to actuate one of the working parts of a driven mechanism. That is, the application is it is in the metal cutting machines and the paper making machines, rolling machines. The drive of multi-motor drive systems. It is here the example for the crane system. In this crane, the load is the one single. There is only one load is there, but there is a several mechanism of electrical drives are required to lift and to make a position it for that multi-motor drive is used. The choice of electrical drives it is based on the based on the number of factors, that is the steady state operation requirements. It is the nature of speed torque characteristics, speed regulation, speed range, efficiency, duty cycle, and the quadrant of operation and speed fluctuation. The steady state operation is monitor. In the transient operation requirements, values of acceleration, deacceleration, and starting, braking, and reversing performances. And also related to the source, the electrical device has to be chosen, that is type of source and its capacity, magnitude of voltage, voltage fluctuation, power factor, harmonics, and their effect on other loads. And the capital cost and the running cost, that is investment cost, and space and weight restriction, environment and location, and finally reliability. Thanks for watching this video. If you have any queries, kindly drop your mail to the following mail address.